Well, I hope he isn't seriously hurt. No, he's not hurt at all. Oh my gosh, we're going to lose that puppy over the edge of the stage. But there's a lady right there who will, oh, okay, this lady. Thank you. Okay. Now, what we have here, you see, is you got your basic beach ball. Now, this is not just any old beach ball. This is a trained beach ball. It will do exactly as I tell it, nothing more, nothing less. For example, I place the beach ball on the table. Watch carefully now. Stay there. Did it? Huh? Physics is great stuff. Yeah. Well, you know, you people knew that. See, you people already know some physics because you know that if you set something down, it's not going to move, not unless you give it some kind of a force or some kind of a push or pull, because it has mass, and it is, in fact, Newton's first law. Not only that, but if you get it started moving once, it will continue moving unless you act on it with another force. Hank, are you around here? Are you still, or did you take off?
Right here.
Oh, okay. Why don't you use your head for something useful? That would be good. Now, what I choose to do is to pop this toward you, and you use your head. He'll use his head to pop it back.
All right.
A force here, a force there.
I can do it.
Here we go, like so. Yeah. Whoa. This is pretty good. You can do better than that, and I can do better than that. There we go, coming right back. Now, if he didn't exert that force on it, it would not stop. It would keep going. Not very much, because this is really a pretty light object, very little mass. But there's
I did it for him, right?
Oh, you want me to? Oh,
Yeah.
absolutely.
Use your head.
You bet. Gonna use the head. Watch this.
Jack is not too bright, you know.
I am too. I was so bright, my mother called me son. Absolutely. That's such an old joke.
Now, of course, the more stuff there is, sometimes we say mass, the harder it is to stop something and then get it restarted. So we're going to see, you've heard of the headless horseman, now we're going to see headless Jack.
No, you're not. I can do this.
Yeah.
I'm tougher than you are. I'm tougher than that ball is. Not only that, I'm not as stupid as I look. I would never do that because there's too much mass. And when there's that much mass, it could take my head off. I look terrible without my head. I would never do that. This is all, though, remember, this is all physics. This is fun stuff.
You know, it isn't just solids and liquids that have this property, inertia, but gases do as well. This building right now is full of oxygen, nitrogen, various kinds of gases. And I could take a handful of some of these gases and throw it at you people in the audience, but you wouldn't feel anything because gases are so slippery, they'd go around my fingers and fill in behind my hand and nothing would happen. However, if you happen to have one of these giant puffers, which I made in my workshop, they allow you to throw a chunk of gas with the thing and actually see what's happening. Well, not see it, but you can sense it. So I'm going to puff a chunk. Now Hank is lighting a candle. I recently had a birthday party, and I contributed to global warming.
Now we're going to try to blow this candle out by throwing a glob of air at it from that puffer.
Well, that's nice, but it's still irritating because you can't see what's happening. And it would be much nicer if we could see what's happening. Does the air come out like a basketball? Does it come out like a cube? Maybe the letter B.
Maybe.
What? But what if we fill the puffer up with some fog?
Now, John, when I get this full, I don't want you to let any get away before you do it.
I have very large hands, and I can guarantee you that every bit will stay in there.
Okay, I'm ready.
I'm ready
It's
too.
full. All right.
Okay. I hope you're all convinced now what shape it is.
Now there's something that we call friction, and friction does something pretty interesting because it sort of holds things together a little bit like glue. So I have these wood blocks that if I push with this claw hammer on one of them, that block will move. If I push on the one down below it, they'll move as a unit. So it makes things stick together, and if I push them just a little bit, they move together. But if I push them real hard, I can make it so that they act independent of each other. I can even, if I can do this, take the one out of the middle. So sometimes friction with a little push makes things all act like one, then other times you can make them look like independent things with a big push.
As luck would have it, we have here a machine that will show the idea that when things are at rest, they tend to stay at rest also. What I have here is your basic telephone. I mean, a tablecloth. It's not a telephone. It's a basic tablecloth. And if you could get me some dishes there, Hank, that would be good. We'll put that plate right there. We'll take this spoon and put right over here. Let's say I want to eat a lot of soup today, and I have a little glass of wine or Kool-Aid. I'll set that like so. Oh, there it is, the Kool-Aid, yes. Now, I need to look at what I have here.
You know what you got?
What?
The ugliest tablecloth I've ever seen.
That is ugly, isn't it? Yeah, if I were to eat on that, I'd probably throw up. So what I'm going to do is I'm going to remove that tablecloth from underneath there using the laws of physics, which says that if something is at rest, it stays at rest unless acted on by an outside force. And so I'm going to...
These have mass too.
They have mass too. Oh yeah, water has mass.
Yeah.
So I'm not going to exert any force on the water or the glasses or the dish or anything. I'm going to exert only a force on the tablecloth and remove the tablecloth from underneath. There's another glass you're putting on it. That's enough.
It's the last one.
The last one. Yeah, it better be because this is sweaty palms time. I could have stuff all over the table and oh my gosh. This always gives me a little. Now you said that was the last one. That's
the last glass.
the last glass. Okay. Well, I can do this. Because physics doesn't lie. That's another glass. I can see that. That's another glass. You can't. I'm old, but I'm not senile. Now.
I made a mistake.
Yeah, you made a mistake. In a pig's eye, you made a mistake. That's enough. Let's just stop it right there. I can do this. But I got to get pumped up. I got to have it ready. I got to have this going. I'm going to make this happen. I need it pulled nice and even. So I put this wrapper on the cloth. Now, don't you try this. Oh, my gosh.
Now,
Wow.
you'll either succeed or fail in the first microsecond because he has to break the friction.
Watch it. He has a... You think I can do this? Yeah. Well, okay, you think I can do this? All right.
Let's give him a 3 count.
On a count of 3.
1.
I'm not ready. No, I'm just not ready. I'm not afraid. I'm not afraid. My rubber ducky. Now.
One more time.
All right, here we go. Aha! Things at rest tend to stay at rest. Thank you very much. Newton's first law of motion.
Jack, could you give me a little help here? I want to illustrate something about inertia again.
Okay.
Would you sit right there on that stool?
I can do that. I can sit on this stool.
Okay. This
All right.
block, Jack, has a
Yes.
lot of inertia.
Yeah, oh, sure it does. It's
It's
a big
at
block.
rest. It wants to stay at rest.
Yes,
and I'd
I
like to
know.
have you bounce this on top of your head.
On my
Could you
head.
do that?
On my head. Okay. All
Oh,
right.
boy,
we'll,
I'm glad
we'll do
you-
that. Okay.
Now,
Now then.
it's at rest. It wants to stay at rest.
Okay.
I'm going to try and drive a nail in this.
Shut up. Are you really? This is crazy. Okay. Ow. Oh. Well, that's no big deal. That works
Now,
easy.
the reason you weren't hurt, Jack, is this has so much inertia that it doesn't want to move.
Yeah. it doesn't-
Remember when we first started this, I took a dollar bill and
Yeah.
put on your head. And then we had to quit that one for a while.
Didn't work at all. Called me Spike for weeks after that. Yeah, that was terrible.
Lots of mass, lots of inertia. It won't go anywhere. That's what saved you this time.
It did indeed. Thank you much.
This is a bed of nails. And these are real nails. In fact, some students at Jack's High School built this because they were interested in how it is that people can actually lie down on a bed of nails, and I will lie down on this for you in just a minute. But one of the things you never do if you have a bed of nails is jump into bed. Because once you're in motion, you tend to stay in motion. So here's a potato playing the role of someone jumping into a bed of nails. We're going to do it sideways so you can see how it looks. But this is how it turns out. It's not a good thing. In fact, the word is impaled. And now there's holes all over the place in the spud, and there's water or juices, spud juices running out. Now, if you do it, it's the same result, but it is more colorful. But the outcome is the same. On the other hand, if I place the spud gently on the nails, it's okay because it doesn't rest on a single nail, it rests on many nails. Each nail holds up some of the weight of the spud, and no nail is so hard against the spud or so much pressure that it pierces even the thin skin of the spud. And it turns out, of course, that humans can actually withstand a lot more pressure on their hide than you might think, several pounds, in fact. So, if I don't jump on the nails, and there is enough nails, then they'll hold up my weight without any nail hurting too much.
Boy, and that's a lot of weight.
All right, so now I've got my head up, my feet up, so that all my weight is on the nails, and I'm not saying it's comfortable, but I don't think I'm bleeding yet.
Let's hear it for Hank, huh? Now, his weight is spread over many nails. I can even add more weight to him, and it still doesn't bother him too much. And in fact, because this concrete block has so much mass, I can actually hit on it with something like a sledgehammer, still won't bother Hank. In fact, I can hit it so hard with the sledgehammer, I can break it. Okay? Here we go. Woohoo!
No harm done.
It's physics, you guys.
It's just physics.
That's all there is to it.
Let's see
No
here.
blood.
Oh, look at that.
No blood.
No holes.
No blood.
Ish.